Okay, welcome to this demonstration of the ID3 algorithm enhanced with gain ratio. So in this video, I'll walk you through how this algorithm works, why gain ratio improves the decision tree classification, and how it's implemented in practice. So here is the start by importing the necessary libraries. The math module, which task is for mathematical operations such as calculating logarithms for interpret. The counter class from the collections module will be used to count occurrences of different values in the dataset, which is essential for calculating probabilities. So for the dataset overview, the dataset used in this demo contains features like weather conditions and whether to play sports, as these datasets have been used in some researches testing the efficiency of ID3 algorithms. So the goal here is to classify whether to play sports based on the weather features. Next is to define functions that form the backbone of the ID3 algorithm with gain ratio. Entropy calculation. The calculate entropy functions computes the entropy of the dataset. It calculates how uncertain the data is by summing up the weighted probabilities of class labels using the formula. The counter class is used to count occurrences of class labels in the dataset, and we calculate entropy based on these counts. Splitting the dataset. The split dataset function divides the dataset into subset based on specific features and its value. This is a crucial step as decision tree splits them recursively to create branches. Information gain calculation. The calculate information gain function determines how much a feature reduces uncertainty. It first calculates the weighted entropy for all subsets, creating by splitting on a feature, and then subtracts this from the base entropy of the dataset. Intrinsic value calculation. These functions compute split information, which normalizes information gain to count for the distribution of features values. This prevents bias towards features with many unique values. So this function collectively enable the ID3 function to select the best features for splitting the dataset, ensuring balanced and meaningful decision tree constructions. Now, the next is to define the main function for implementing the ID3 algorithm with gain ratio, which constructs the decision tree step by step. Check for pure classes. The function first checks if all examples in the current dataset belong to the same class. If they do, it creates a pure node with the class as the label and stops further splitting. Handle case with no remaining features. So if no features are left to split on, the algorithm selects the majority class from the current dataset as the output, ensuring a valid classification at this point. Calculate base entropy. The entropy of the dataset is calculated to serve as the base uncertain before any splits are made. Compute gain ratio for all features. For each features, the information gain and intrinsic value are calculated. The gain ratio is computed as the normalized value of information gain divided by intrinsic value. So this ensures the algorithm select features that provide meaningful and unbiased splits. Select the best feature. The feature with the highest gain ratio is chosen as the root or decision node for the current subset, as it determines the primary splits in the decision tree. Split the dataset and recursively build subtrees. The dataset is divided into subsets based on selected features value. The algorithm is then called recursively on each subset with the remaining features until all the data is classified or no further splits can be made. Next is construct and return the decision tree. The recursive process builds the tree from top to bottom, returning a structured dictionary that represents the final decision tree. So this function encapsulates the entire workflow of the ID3 algorithm enhanced with gain ratio, making it a robust tool for building accurate and interpretable decision trees. Now, let's try to run this implementation. Okay, let's look at the output of the algorithm with gain ratio, which shows the step-by-step construction of the decision tree. So the algorithm starts by calculating gain ratio for all features. So in this case, outlook features has the highest gain ratio of this result. So it is chosen as the root node of the decision tree. So moving on, splitting on outlook. The dataset is divided into 3 subsets, as we can see, overcast, sunny, and rain. So for overcast, all examples belong to the same class. So yes, so it becomes a pure node. So for sunny features, the gain ratio are calculated again, and humidity with the gain ratio of this result is selected as the splitting features. So this branch classifies normal as yes and high as no. So for the rain, wind with the gain ratio of this result is chosen as the splitting features, classifying weak as yes and strong as no. So to conclude, this decision tree demonstrates how the ID3 algorithm with gain ratio constructs an interpretable and accurate model for classification tasks. It selects features systematically, ensuring balance, space, and avoiding biases associated with traditional information gain. So this final output is both concise and effective, highlighting the power of the algorithm in handling real-world datasets. So that's all. Thank you.